Hello, this is Mr. Michael, professor in National University, Ethiopia. Today we're going to talk about the next topic of our course, and this is entitled MATLAB Fundamentals. Okay, so here in this chapter, we're going to well, you have to install MATLAB by yourselves, and then you can download it. There are some free license for that, and then you can try MATLAB. Okay, and then here in this chapter, I will just introduce to you MATLAB, which is one of the, in my opinion, it's one of the best technical computing language. So many languages nowadays, C++, Java, something like this, but MATLAB is, for me, it's a high programming language typically devoted to technical computing. So in this course, numerical methods, we will be using MATLAB to write our program. Okay, so the chapter objectives in this course is are learning how real and complex numbers are assigned to variables. So we will try to do this one. Next is learning how vectors and matrices are assigned values using simple assignment, the colon operator, actually it's colon operator, and the lint space and lag space functions. Next is understanding the priority rules for constructing mathematical expressions. And lastly, gaining a general understanding of built-in functions. There are several built-in functions in MATLAB actually, and there are thousands of them, but we will only use few built-in functions like sum, like square root, something like this. So I will introduce it to you as we go on. And lastly, learning how to use vectors to create a simple line plot based on an equation. So, well, before we start, we really have to open MATLAB. Yeah? Okay, so what we will do is let's, well, in my computer, I already installed MATLAB, so I will open it. Okay. So we will just wait for a while, and then anyway, while waiting, let's move the screen first. The MATLAB environment. Okay, so there are three windows, basic windows in MATLAB. The first one is the command window, and this is used to enter commands and data. What we are going to do here is we will use MATLAB as a calculator actually. Okay, here MATLAB now, it's open up. So let's try to maximize this one. This is the command window here. Okay. So here you can write you can make MATLAB as a calculator. For example, 1 plus 2 plus 3. So what happened here is when you add the numbers 1 and 2, it gives the value, it stores the value to the variable ans, and then ans is equal to 3. If you say 3 plus 5, like that, if you write square root of 4, this is the function actually, like I said, and then you enter it, that is 2. So this is the command window that I'm talking about. And then we have here also the graphics window. Okay, in the graphics window, it will just pop up if there is a plot option, functions that you wanted to activate. Like for example, you are plotting a function, so you need to, it will just pop up. Okay, last one is the edit window. For example, if I will edit here, this is just an example. I will make a function. For example, I will call it function Michael. For instance, I will write edit and then Michael, and then when I hit enter, let's see what will happen here. this is the MATLAB editor. It says that it does not exist. Michael.m does not exist, which is an M file. We will talk about that in the next chapter. So let's just try to okay, let's say yes. Untitled document. Okay, we can do that. It says that we will make it up here. So this one, that's untitled document, but if we will write again, edit Michael, let's do it again. Michael, for instance, here, okay, this is the name because we are in this folder. We will go to a different folder first, I'm sorry. So let's say, let's just go to somewhere here, MATLAB, for instance. Okay, something like this, or say, it's up to you. You can go anywhere, whatever you like. You can, let's say, I want to go to, let's say, Bluet folder, for instance, and then, okay, there. Okay, for example, like that. So we are in that folder. This is an example, and then you say, edit Michael, for instance. Okay, it will open an M file in that folder. Okay, so last a while ago was in System 32 Windows files, so that is not possible. So here we have now here in this folder. Okay, so this is the edit window that I'm trying to say. Okay, next here is okay. Okay, let's move on. Calculator mode. Okay, calculator mode, like I said, is you are making the MATLAB as like a calculator, and then you will do that in the command window. So I think it's better for not to just exit this one. You will do it here. Okay. So by the way, I will write CLC. CLC means to clear the screen. Okay. And then clear. We will to clear this workspace here because there is a memory now stores in the variable ans. We will say clear. Okay, it is now removed. So the calculator mode is command window. Okay, like I said, and whenever a calculation is performed, MATLAB will assign the result to the built-in variable ans. Just like I said a while ago. Again, 1 plus 3. Okay, ans is equal to 4. Okay. Example, 55 minus 16 is equal to 39. It's just something like this in my example. Okay. Next, MATLAB variables. While using the ans variable may be useful for performing quick calculations, its transient nature makes it less useful for programming. Of course, most of the time we will be assigning a value to a variable, not necessarily ans. Okay, so we can write it this way, like a equal to b. A equal to 2. For instance, a is equal to 2. Like that. So a is equal to 2. That is the variable. So as what MATLAB says here, it can store individual values as well as arrays. Okay, we will talk about that as we move on in the next chapter, but not so much really with everything in MATLAB because it will make it will make the course more difficult for you, and simply we just need to understand the core of MATLAB. The most important thing, we can make a program, something like this. So okay, let's move. Scalars. How do we write scalar in MATLAB, or a vector or an array, something like that? So we will explain that. So to assign a single value to a variable, just like what I started here, a equal to 2, simply type the variable name, the equal sign, and the value. So you say a equal to 4. Have you seen this part here, this one? So when you see that one, that's the time that you will start writing your command. So when a equal to 4, a is equal to 4. So you mean to say you assign the value 4 to the variable a, okay? And it has a memory, a certain piece of memory in the computer which it was assigned to. So a here is 2, and our answer is 4 from a while ago. So it's just something like that. Next, note that variable names must start with a letter, though they can contain letters, numbers, and underscore symbols. So what I'm saying here is, for example, let's say Michael is equal to 4. This 4 like that. Michael is a valid variable name, or even if you make it m and then like that, equal to 4. This one is another variable, simply because MATLAB is very specific. If you look at here, this is lowercase, this is uppercase, and there is a big difference with that, okay? In MATLAB, they are not the same. Now, if I will start with a number, say 1, Michael is equal to 3. You see this one, there is an error. Error, unexpected MATLAB expression. Why? Because we started with a number. Or if you start with a underscore here, for example, Michael equal to 4, still it's not possible because we started with a character here other than a letter. So the input character is not valid in MATLAB statements or expressions. That is not possible. Okay, MATLAB will get angry if you will do that. But if you will put inside Michael, say v equal to 4, that is possible because the underscore is somewhere in between of the name of the variable. Okay, and even with a number, okay. Something like that, right? So you can tell MATLAB not to report the result of calculation, of course, by putting a semicolon. As you can see here, we put here Michael V and then without a semicolon, and then immediately Michael V comes out in the command window. Michael V is equal to 4. But if you will put here a equal to 4 and then something like that, it will not come out, okay? But it will store the variable immediately here in the workspace. For example, if you say Michael, or say Michael Williami is equal to 4, then like this, it's not echoed in the command window, but Michael Williami is found there in the workspace, something. Okay, it's just like this. So that's what I'm talking about. Now you can ask MATLAB to report the value stored in the var by typing its name. Okay, so, well, if you want to see what is the value of Michael V, Michael V is equal to 4. What's the value of Michael? Michael is equal to 4, as you can see here in the workspace. Okay, so let's proceed. Now you can use a complex variable I or j to represent the unit imaginary number. I will I will explain it in detail in the future slides. We will talk about that. I and j, we can use it as a variable actually, but most of the time it would have been better if we will use it as a complex variable, because it is really devoted for that. If you remember, the square root of -1, that is I. So yeah, so if you call I, and then MATLAB will immediately know that one. So as much as possible, my recommendation is do not use that as a variable. There are several names, variable names that we can do. Just do not use I or j. Okay. Okay. I hope it's fine. Right. So this one, you can tell MATLAB to report the values back using several different formats, using the format command. Okay. As you can see here, Michael V is equal to 4, Michael V is equal to 4, and then we will try to write some things. By the way, there's another built-in function, pi. So I think you know what is the answer here. When I hit enter, pi 3.1416, that is the value of pi, the ratio between the circumference and the diameter of any circle. Now, this one, as you can see, 3.1416, there are only 4 significant figures on the right side of the decimal point. It means that there is a format here, and this format is default to be short. Okay, so I will show you here. Short is scaled fixed point format with 5 digits. Okay, so it's something like this. Now if you say long, and then you will be having 15 digits for double and 7 digits for single. Short eng, so okay, it's there. The example, it's in the slides, so we will see that one now. Okay, so format short, sorry, pi ans is equal to 3.1416, so it's somewhere there. But if you say format long, and then okay, it will not be a code, and then you say pi, that is pi. You see, it's totally different. If you say how is equal to 1, 2, 3 point, like that. Okay, that is how. It's written in this form also. It was written in scientific notation, but this is the format long. But if you say format short, and then how, okay, as you can see, that is a difference. Okay, so you can see here format short eng pi 3.1416, okay, and then pi times 1000. All right, so these are the formatting, but normally in MATLAB it was really in short format. Okay. Okay, arrays, vectors, and matrices. So I think we knew what is a vector. Maybe array, you are a little bit confused about that, but you have met array before in computer programming, and in MATLAB it's quite easy to do that. But I would say we will just limit in matrix. So a matrix is like a two-dimensional array. Okay, so let's do that. MATLAB can automatically handle rectangular arrays of data. One-dimensional arrays are called vectors. So, well, there is a row vector, a column vector. It will be discussed here. And two-dimensional arrays are called matrices, just like what I said a while ago. Now, arrays are set off using square brackets in MATLAB. So, entities within a row are separated by spaces or commas. Let's just finish this one before I make an example. Rows are separated by semicolons. Okay, so what does it mean? Let's say I will write here A, I will say matrix. Matrix is equal to, like that, brackets, and then I will say, remember rows are separated by semicolons. So if I will put like this, 1, 2, 3, 4, this is a column vector. We will see what's the result here. So matrix is 1, 2, 3, 4, column vector, one column. But if you write like this, matrix, say row, for example, and then bracket 1, 2, 3, 4, and then close, that is a row vector. Okay, I think you have seen now the difference. It's quite easy. This is a vector. So looking at some examples here, our examples. Okay, we have that one. A is equal to 1, 2, 3, 4, 5. A is equal to a row vector, and then a column vector. B is equal to 2, 4, 6, 8, 10. You have a column vector. It's just something like this in my example. Okay. So note, MATLAB does not display the brackets, of course, but when you call or you make a matrix or a vector, you need to put the brackets. No need to initialize here like math like that in C, C++. Here, immediately write it, because that's why, by the way, that's why the name is MATLAB here. The meaning of MATLAB is Matrix Laboratory. Okay, it's like this. Matrix Laboratory. Okay, so that is the meaning of MATLAB. All right. So that's why all the things here are being, the main format is really written in matrix. And if you're using a monospace font, such as Courier, the space value should, okay, not that much important. Matrices. Okay, like I said, this is a two-dimensional array. Okay, so how do we make now a two-dimensional array? A while ago we have what is this? Column vector, and this one is a row vector. What about now if you want to have a matrix, say 2 by 4 matrix? Okay, so according here, the data is entered row by row with spaces or commas separating entries within the row and semicolons separating the rows. Okay, so for example, when you say matrix again, another matrix is equal to 1, 2, 3, 4 semicolon 5, 6, 7, 8 9, 10, 11, 12. Okay, so as you can see, it's very obvious. There are 3 rows and 4 columns. Here we go. So we hit enter. 3 rows, 4 columns, and that is a matrix. They are separated by this semicolon. Alright, something like that. Useful array commands. Transpose operator. Actually, this one is very important for us in the future chapters. Right now, I will just introduce this one. When you put an apostrophe here, you will make a transpose matrix of a certain matrix. For example, let's remember first matrix here. Let's go back to matrix. If this is the matrix, which is a column vector, if you say transpose and then matrix is equal to matrix, and then you put there this one, an apostrophe, you convert this into a row vector, something like that. Okay, so that operation is what this is actually the transpose matrix. It has some importance in the future chapters, which I will explain to you, and I will show you also for another matrix. Let me see what will happen here. So if you say transpose another matrix is equal to another matrix, like that, what will happen? Can you guess it? Okay, here we go. Okay, so all this first row, it becomes the column. This one, all the second row becomes the second column, and this one becomes the third column. It's just like that. Okay, and that's the transpose of this another matrix. So the command window will allow you to separate rows by hitting the enter key. Script files and functions, we will talk about that in the next chapter. And new line, okay, we will talk about that. The who command will report back use variable names. Okay, whos will also give you the size, memory, and data types for the array. So if you want to say who, what are the variables? You are asking, what are the variables in the workspace? So who, your variables are Michael, A, and the matrix, and ANS, and all of this. So you are asking the computer, the MATLAB, what are the variables that are already been used in this program. So if you say who's Michael, who's Michael? Michael is a size 1 by 1, is a scalar, 8 byte, and a double, class in double, something like Michael. The value of Michael, let's look at that, is 4. That means that it's just a scalar, okay, and that is a double. Okay, so we will talk about that class as we go on. Okay, so that's what I'm saying. And here accessing array entries. Individual entries within an array can be both read and set using either the index of the location in the array or the row and column. For example, this is the matrix. Okay, this is a 4 by 3 matrix. Now the numbering here, I think it's better we will write here in our own another matrix. Okay. Now the numbering here starts from this one. This is 1. This is 2, 3, like that. So if I will say another matrix, if I will call another matrix and then say 1, when I hit enter, the value of that is 1. This is the first element. Second element is here, and this is the third element, fourth, fifth, sixth, something like this. So hit, okay, that's equal to 1. So according here, the index value starts with 1 for the entry in the top left corner of an array and increases down a column. So it finishes the first column. After that, it moves to the second column. Okay, so there are some examples here. Okay, assuming some matrix C is equal to this one, or in our, we can also use our own, but if you want that one, we can write that C is equal to 2, 4, 9, 9, 3, 3, 16, 3, 0, 18, and 10, 13, 17. Here. So if you say I want C2 would report 3, is that correct? So 1, 2. Okay, let's do that. C2. That's equal to 3. Okay? So if you say C10, what is C10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C10 is equal to 16. That's it. Okay. C4 would report to 10. C13 would report an error, of course, because the maximum elements here is just simply 12. So beyond that one, that is out of bounds here. That is, it's not anymore. It's not defined. C13 is not defined. You can also use row and column. Like if you say first row, for example, I will write here C1, 3. I'm saying here that C1, row 1, third column. So row 1, third column, that is equal to 9. Hit enter. Okay. If I say C3, 2, third column, third row, second column. Okay, so that is the element. It's a value. So we will see from the slides. C21 would report 3. Is that correct? C21 would report 3. Okay. Next is C32 would report 0. 1, 2. Okay, that is correct. So let's go back a little bit. 2, 1, 3, 3, 2, 0. Okay, that's correct. 5, 1 would report an error. That is out of bounds. Okay. Array creation built in. So there are several built-in functions to create arrays. Zeros RC will create an R row by C column matrix of zeros. Okay, so for example, if you say I want to say Mike is equal to zeros and then 5, 5, 5. Okay, or say 3, 3, 2, for instance. So the answer here, when we hit enter, Mike will be equal to a matrix, 3 by 2 matrix, wherein the values are just simply zeros. Okay, 3 by 2 matrix. That's what I'm saying. Okay, zeros n will create an n by n matrix of zeros. We'll do that. Ones RC is just the same with zeros, except that the values are not 0, they are ones, but it behaves the same. And then ones n will do just something like, okay, help LMAT, element matrix, help. If you need other things, you can ask MATLAB, what are the other functions that I need to learn. You can do that. Okay, let's write zeros 5, it will make, and 4, it will make a 4 by 4 matrix. Okay, but if you hit 0, 4, 3, it will make a 4 by 3 matrix of zeros. Okay, like that. Now if you use ones, 4, okay, 4 by 4 matrix, and then so if you write like this 4 4, no need. It's just the same effect with ones 4, so don't do that. Ones 4 3 5, for instance, like that, 3 by 5 matrix. So that's what I'm saying. So you will realize the importance of this as we move on to programming. For now, it's quite better that you learn how to make a window, how to do like this. We will. This is quite easier for you. Now, colon operator. What is this? Okay. The colon operator is useful in several contexts. It can be used to create a linearly spaced array of points using this notation. Start, differential, diff value, then limit. So it's just like this. If you say 1, and then 2, and then to 10, so what do you expect? So it starts with a number 1. Oh, okay, let's write first letter. A is equal to, like that, it will be better. So A starts with 1. Actually, this is the answer here is a row vector. 1, and then the interval is 2, and then up to 10. So what do you think are the values here? So you have 1, and then it jumps 2, and then 3. 1, 3, 5, something like that. So when you enter here, oh, so it's anyway, let's go to the slide. Okay, anyway, here there's something wrong. I don't know what happened, but here let's go back to this colon operator. 1.6 and then to 3. So the difference is 0.6. So starting from 1, and then the next value will be 1.6, then 2.2 up to 2.8. The maximum value should be 3. Okay, so let's try to escape to Control C, like that. Okay, let's do it again. A is equal to 1, let's just copy that one, 0.6 or 0.5, that's better, and then to 3. Okay, here we have like this: 1, 1.5, 2, 2.5, 3. So this one is the starting number, this is the interval, and 3, that is the final number. So that is the limit. Okay, so that is the colon operator. Colon operator is very, very important in MATLAB. It can do a lot of things. We can sometimes in other programming language it needs a for loop, but here, as much as possible, we will not use for loop if we can do it like this. I will talk about that, the for loop. You have heard that one in your computer programming before, but we will do it again here. So if you write, say, what else? B is equal to 1, 2 to, say, 21. Hit OK. So we have this one: 1, 3, 5, 7, 9, up to 21. But another thing is, if you say C is equal to 1 to 21 with no default limit, by the way, I mean the difference values here at the center, the default is 1. So when you hit enter, if you write 1, 2, 3, 4, 5, something like that, because there's no different, how do we say that one? A common difference, okay, there, and then the default is 1. Okay. So, okay, I think we already talked about that. So 3 to 6, no, the value is omitted, so you have 3, 4, 5, and 6. Next is decreasing series. That is possible. Instead of increasing, you can also write, let's say 5, what is that, negative 1.2 to 2. So the value is decreasing. So we have 5, 3.8, and 2.6. And then minus 1.2 is less than 2, so that is now the final value. So if you want to decrease from higher number to lower number, you can put a negative here. That is possible. So well, if you make a mistake, you started from 5 and then you end with 2, so 5 2, there will be no value here because we didn't put the common difference. And then remember, the default here is 1, it's not -1. If it's -1, if you say 5 2, that's 1 by 0. It's nothing. Okay, so I try to clear here, and then I clear also the workspace so that everything will be fine, and then it will be, to remove all the workspace here. Let's move on to the next slide, linspace. Okay, so linspace is just simply you want to create linearly spaced numbers points between two numbers. So for example, this is the command linspace x1 x2 n. So like in this example, linspace 0 1 6, it creates 6 linearly spaced points from 0 to 1. Okay, let's write this one and hit enter. So from 0 to 1 there are 6 points, 1 2 3 and then 6. So there are 6 points, and the meaning of this is you write first here the first interval, lower interval, then the upper interval, and then you have here the number of space points, 6. So if you write here linspace, if you forgot to write a number of space points, the default is 100. So from 0 to 1 there will be 100 space points, and that's around 0.01 each. So 0, 0.01, 0.02, 0.03, something like this. Okay, so we will look at the slide. Okay, 100 points are created. That is the default. And if you want to create a column, because this is a row vector, you can transpose it just like what I told you a while ago. Log space is similarly the same with linspace, except the fact that the space are logarithmically spaced. Okay, we will try to see that one here. Row vector with a specific number of logarithmically spaced points between two numbers. Okay, so we will use the log space command. So look at this one. I think there is an example here. I think we can try that. Log space -1 to 2 4. Okay, we'll try to do that. Let's start with linspace first so that you can see the difference. -1 to 4. What does it mean? From -1 to 2, 4 points. So that's 1. The common difference, -1, 0, 1, and 2. But if you use log space, -1, 1, 2, and 4, it means 10 to the -1, which is 0.1. 10 to the -1 is 1 over 10. And then 10 squared is 100. So there are 4 logarithmically spaced points between 10 to the -1, which is 0.1 to 100. That's what it means by log space. And it's the same thing if you will not put a number at the end, or you give only 2 numbers, 2 intervals, then the default is 100 points. Okay, and the same thing, you can put an apostrophe to transpose the vector, row vector to column vector. Character strings and ellipses, not so much important in our course, because this one is really in programming, MATLAB, when you're starting to program in arrays, characters, something like that. But like I said, in our case, in our application, we will be implementing in technical computing application, so we don't need this one. Okay, what we need is more on how to code MATLAB, but I will just talk about this. So when you put a variable, when you assign a variable, to say f is equal to miles, but then the miles, that's a word, it's a character, and then you put here a apostrophe, something like that, then you are invoking a character format. The class. It's like a how do I say this one? It's a it's a character, like, and which is not the same with double. Like for example, when you say Mike is equal to 5 or 4, for instance. Okay, when you say who's Mike, Mike is double. Okay, it's a number. You can add it. You can you say 4 plus 5, like that. You can make it 9. But when you say Miles, who's F? F is car. Okay, this is the class. Technically, in other programming language, you cannot add immediately this one, but MATLAB is very intelligent. When you try to hit, let's say total is equal to F plus Mike. In other programming languages, you cannot do that because this is a character and this is a integer. I mean double, float. It's a float actually, but here it seems like you can do it. It's because MATLAB is very intelligent. It converts F, the MILES, into a number, equivalent number, and then add it by 4, and so you have this one here. This is the total here, as you can see. Okay, so it's quite weird in MATLAB, but anyway, we will not be doing like this. Anyway, I'm just showing it to you. Now, look at this one here. F is equal to Miles and S is equal to Davis, so we will add again F is Miles, S is equal to Davis. Okay, so let's say this is a name, and then if you like to call Mike Davis like that, how do you do that? You will simply say concatenate. That is the name, I mean the term, concatenate, and then you say FS. You have Miles Davis. Okay, so it's like you add them. Okay, concatenation, pasting together strings, something like this, FS. So you have Miles Davis. Okay, if you look at here, the difference between in the MATLAB is, and here there is spacing, because if you look at our Davis, F, Miles here, no space, but look at there is a space. That's why when you concatenate them, there is a space here, Miles Davis. So if you will do it again, F is equal to like that, and then space like this. When you say concatenate, let's, okay, concatenate is equal to FS Miles Davis. Okay, update it. That's what I'm saying. It's like adding two strings together, like Michael and Jordan. You add them, it will become Michael Jordan, something like that. But if you use plus, if you say F plus S, let's say total, if it's possible, F plus S. Let's see, matrix dimensions must agree. It's not possible. Why? Miles is how many numbers here? 5, but S is only wait. F plus S. What is it? By the way, let's look at F here, because when you use plus, we are using a double. But for now, let's not talk about it for now. Okay, so that is not possible. Matrix dimension must agree. Okay, let's move. Ellipsis. Okay, something like this. Actually, if you are writing in a command window and it's very, very long, and then you want to go to the next line, you have to put something like this. The meaning here is just carry on. For example, I will write here A is equal to 1, like that, so many numbers, and then it clutters here until here, and then no more going to the right. You will be forced to go to the next line. So if you want to extend A, because if you do like this, you cannot just enter it. It's an error. By the way, let's hit Ctrl C to escape the error, like that. So let's go back. I hit up arrow here at my keyboard to do that. So if you want to extend A, like that, and then add here the bottom, let's say 4, like whatever, and then here. Then A is added 66 with 4, 5, something like this. Okay, so who's A? A is a 1 by 14 row vector. Okay, that's what I'm saying. But for characters, you cannot do like this. When you add code and this one, any fool can make a rule, and then you cut that one, and then you just immediately, okay, I will show you to make it easier to follow. Code is equal to let's say sorry, I made a mistake, equal to, let's say, this is an array, I mean a character. Any fool can make a rule, and then I will do like that, and then I will hit enter. That is wrong. Okay, you cannot do that. Instead, go back. Let's go back. Before you do like this, the ellipsis, you put here first a this one, so that the MATLAB will know that it is a character, and then you continue in the next line. Okay, so do it again, and any fool will mine it, close. Okay, and then you have the code, something like this. Okay, I think it's quite easy to follow, but I'm just telling this to you, but it's not really our main, we will not talk much about this. Okay, we are more concerned on computations. So mathematical operations, already mathematical operations in MATLAB, you can, of course, you can add them, you can subtract, you can make an exponent. Okay, it's written here in the table. Exponentiation, so you use this, I forget how to say this one. It's, for example, you say 4, and then you say shift 6, by the way, and then squared, it means 4 squared. You see that one. Okay, it's a hyphen. This is 16, so if you use multiplication, you use the asterisk, or the shift 8, 2, then shift 8, and then pi, mean to say 2 times pi here, 2 times 3.14, we will see 2 times 3.14, 16. It's the same, so that's what I'm saying. And then left division, okay, that's divide, so 6 divide 2, divide 2, like that. Okay, 6 divide 2 here, that is 3. But if you say the other division, the left division, that is it's this, by the way, I will explain this one. 6 like this is like 2 divide 6, that's why we have 0.33. But if you do like 6 divide 2, this is, what is this, backslash, we have this 160 over 2, and we have 3. Okay, careful that, okay, they are quite different. So if you write 6, then this one forward slash 2, this is just simply equal to 2 divide 6. They're the same. Okay, so careful. Order operations, of course, we'll start with the parentheses and the exponents. Okay, like this. The order operation starts from the, if no parentheses, it should be the square. So as you can see, this one, y is equal to -4, then squared. So you square 4 first, which is 16, and then you attach the negative sign. That's why it becomes something like that. And then, but if you put parentheses, so let's say y is equal to -4 and then squared. So 4 is squared first, 16, and then you have -16. But if you do like this, y is equal to -4, then squared. So this is -4 times -4, 16. Okay, it's positive 16. Okay. Complex numbers, this is what I said a while ago, that that I and j are devoted for complex numbers. So how to write this one? Remember I and j? So if you want to write a square root of -1, that is just simply I. This I will write I here, and you see 0 plus 1i, meaning to say I is the square root of negative 1. I has a very special representation in MATLAB, that it's already been written in complex numbers. So when you write I, it's not like M. When I say M, undefined function or variable M. So M is, MATLAB doesn't know about that. We didn't write a number or a variable for that, or a value for that. But when you say I, what is I? It will give us immediately this one. So these are the examples. X is equal to, say x is equal to 2 plus, 2 plus I times 4. So it will say, it will become 2 plus 4i. Okay. So what else? Y is equal to 16. Okay. By the way, I put a semicolon, so it's not a code in the command window. And you will say 3 times x, what is that? That is 6 plus 12i. Let's see. Okay, 6 plus 12i. Okay, something like that. X plus y. Can we do that? X plus y. Of course we can do that. X plus y is 18 plus 4i. Okay, and so on. Okay, so that's how MATLAB do the basic computation. Okay. Vector matrix calculations. So MATLAB can also perform operations on vectors and matrices. So I will show you how. Really, I want you to understand this one, but this is needed in future chapters when we talk about the linear systems of equations. But for now, we will talk about this. Okay. When we see this, if you multiply a matrix, what will happen? There is what we call matrix multiplication. Okay. And it's somewhat different from a normal multiplication, actually. So the number of columns of the first matrix must match the number of rows in the second matrix. What does it mean? Let's write here let's make a 1, 2, 3, 4, 5, 6. So 2 by 3, 2 by 3 matrix. Made a mistake, I'm sorry. 1, 2, 3. Equals. I forgot, sorry. Okay. A, 1, 2, 3, 4, 5, 6. Okay, let's say B is equal to 1, 2, 3, 4, 5, 6. This is a 3 by 2 matrix. Okay. Now, when you multiply, okay, we will look at first the slides. The number of columns of the first matrix must match the number of rows in the second matrix. Okay. Let's look at who's A, B. Okay. A is 2 by 3 matrix, remember that? And who's B? Sorry. 3 by 2 matrix. Now, the number of columns of the first matrix, this is row, this is column, must be equal to the, what is this? Must be equal to the number of rows in the second matrix here. So, if you do A times B, that is possible. Okay, let's do that. Here, this is the answer. A times B. Now, let's go to I will not explain so much about that for now. There is a matrix multiplication. How does it occur? How does it happen to be like this? Anyway, the size of the result will have as many rows as the first matrix and as many columns as the second matrix. So, if you look at A is 2 by 3 and B is 3 by 2. It seems like you cancel this 3 and 3 and the product is 2 by 2 matrix, which is this one. Okay, that is matrix multiplication. How does How does MATLAB do it? We will talk about that in future chapters. Okay, so the exception to this multiplication is a 1 by 1 matrix, of course, which is really a scalar matrix. Now, that one hyphen operator for matrices results in the matrix being matrix multiplied by itself a specified number of times. So it's like, let's say A here. Let's go back to A. If you say A and then squared, it means that is matrix multiplication of A by itself. Let's see the answer. Oh, why? Oh. This is A times A. I'm sorry, this is not a square matrix, so I forgot. As you can see, note in this case the matrix must be square. Okay, let us make another matrix. Square matrix 1, 2, 3, 4, 5. This is my favorite matrix because it's very easy to write. 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say C and then squared. So we have this answer, a 3 by 3 matrix. What does it mean by C by C? It's just like C times C. Is it the same? We will see. Okay, the answer is the same. So you square the matrix. So the output here is quite different, which I will really explain that in the future chapters. But for now, it's different here. Okay, there are some next slide here. I think you will ask. I thought when we will use C squared, for example, 1, 2, 3. When I say C squared, the answer will be 1. This should be 1, 4, 9, 16, 25, 36, 49, 64, and 81. But the answer is different. Why? Okay, we will talk about that. So if you want to have an output something like that, 1, 4, 9, 16, 25, 36, 49, 64, and 81, the technique is you do like this. Okay, the technique is some C, then dot, and then like that, and then squared. There should be a dot. When you hit that one, the answer is 149. Let's look at C again. So this is an element squaring of each element inside the matrix. So remember of that dot sign. It's quite different if you remove that one, because this one is squaring of the matrix, and like I said, this is element by element, but C squared, that is matrix multiplication by itself, and it's different. Okay, yeah, I told you in the next slide. So element by element calculations, I explain it here. If you want to do that, you put a dot, either by multiplication or division or squaring the matrix or raising it to power, doesn't matter. So let me write this one. For example, let's say A here. Let's look at A again and B. A and B, matrix multiplication, possible. Is it possible to multiply this one element by element? What do you think? Oh, it's not possible because matrix dimensions must agree. So if A is a 2 by 3 matrix, you can multiply it element by element to another 2 by 3 matrix. So let's say D is equal to let's say equal to what? Say 6, 7, 8, 9. 6, 7, 8, 6, 7, 8, 9, 10, 11, for example. Let's review again. A. So A, then that multiply to D. What is the answer? Of course, you know that one. 1 times 6, 6. 2 times 7, 14. 3 times 8, 24. Okay, it's something like that. 4 times 9, 36. 5 times 10, 50. And 6 times 11, 66. You can do this element by element as long as they have the same size. Actually, the term is size. same row and column. Okay, I hope you understand. Built-in functions. There are so many built-in functions in MATLAB, but we've been using some of those a while ago. We use the square root. What else? The pi. Okay, it's a function actually. So there are several built-in functions here, and then you just use this help lmat and then help lfun. You want to see some basic functions, lfun, like sine of the sine. What is sine of pi, for example? You want to see sine of pi. What is that? That is 0. Okay, it's almost 0. Now, why is it not equal to 0? Because sine computes it like a numerical methods. Okay, that's the answer. We will talk about that. When your sine pi is 0, but there is something like a number here. Why it becomes, although it's almost 0, e to the negative 16 is very, very small. So why it becomes like that? We will talk about that in the future chapters. Why it's not really 0? Why there is a small number? There are some errors. We will talk about that. Now, sine pi. Okay. Sine pi. This is really a. This is. It's not using degrees. It's using the radians. Okay. But if you want degrees, sine d, you put d, and then say 90 degrees. What is that? Of course, that is equal to 1. Okay. So there are so many built-in functions. So you just go to help lmat or help lfun and then read, and then you'll know a lot of things. Okay. Next, look for command will search help files for occurrences of text and can be useful if you know a function's purpose but not its name. So, for example, you do not know the function, how to compute the tangent of a function. So I would just write, say, look for tangent. So MATLAB will scan all its functions and then will tell you, maybe you're looking for these functions, maybe this function is fit for you, something like this. Let's hit OK. Look for tangent, and then MATLAB will tell us. Okay, these are the possible functions: acot, inverse, cotangent, result, and radian. But if you put d, it will become degrees, and all of this. Okay, that's what I'm saying. Okay, so let's move on. Graphics. We can, like I said a while ago, there is a command window here, and there is also a graphics window. If you want to plot something, I will show you afterwards. It will pop up another window, and that is a graphics window. Okay, so we have this one, plot 3 for 3D data, three-dimensional, two-dimensional, and we can use some of these labels here. Okay, so let's try to do that for a while. Let's say I will write here x is equal to 0 to 10, for example. Okay, and then y is equal to let's say x squared minus 4, for instance. Okay. Sorry. X squared, like I made a mistake now. You see, there should be a dot. I'm sorry, minus 4. Okay, so let's see what is the value of y. Okay, so x squared minus 4. So what is this? 0. 0 then minus 4. Okay, let's plot this one, for instance. Plot xy like that, and you'll see what will happen. Let's wait for a while. It's not coming up. I think it's here. Yeah. All right. This is the graphics window. Another window will pop up as long as you will as for plot. So this is x and this is y. So this is the function. I think this is a quadratic equation. If you let's look at, if you change x, maybe x will be equal to negative 5 to 5, for instance, like that. And then y, let's go back to y. I hit up arrow, by the way. Okay, let's see y. Okay, and then let's plot that one, for instance. Plot again x, y. And then let's see the graph. Will it change? Yeah, it will change. It will update whatever the current plot that you are doing here. So this is now the quadratic equation. Okay, moving on. Plotting example. Okay, we tried it already. So we can just do it in the class. We can just practice it. But somewhat it's just really like this. It's the same. Okay. Here, that is the plot. Okay. I made a simple example here, but I think you understand. And just look at here, there are some functions here. There is a tan h. What does it mean? Hyperbolic tangent. So MATLAB can just understand that square root is QRT. Okay. And then everything. Plotting annotation example. Okay. If you want to add some title here in our plot, so we can write here title, plot of y versus t, for example, like that. X label, values of x, and y label. By the way, let's look at first what will happen here. Okay, plot of y versus t, values of x, values of y, and grid. Do you think what do you think will pop up after that one? When you hit grid, we'll see. Here, these are the grids. Okay, so that's what I'm saying. So many functions here in MATLAB that will amaze you, will amaze us, makes everything easier, very interactive. That's why I choose this program for you. And then let's move on. Okay, that's the same function. Plotting options. When plotting data with MATLAB, you can use several different colors, styles. For example, in this case, this is a blue line graph. If you want here a different style, different color, we can follow this one. Okay, you can go to the help command. So for example, in this plot specifier, if you add RO and then that colon, that it means red dotted line with circles at the point. And GD, green diamonds at the points with no line. So what does it mean? We will try to do that here. Plot XY and then copy that M. Say like this. I'm sorry. M like that. What does it mean? You plot XY and then magenta dash line with no point symbols. We will see what will happen. Okay. This is the plot, and then we will see now. Here we go. It's changed. Magenta and then dash line. Okay, with no point symbols. So there are so many options here. You can read it. Like I said, help. And then you can experiment, you can do a lot of things. Okay, so moving on, other plotting commands, hold on and hold off. Yeah, hold on is like if you want to plot another function here and then you want to remain this plot, this figure one, and then you want to add another plot, let's say, if I think this is x squared minus 4, right? If you want to plot x cubed minus 3x, superimpose in this plot, you can put hold on. Okay, that's what it means. So, example, keeps the current data plotted and add the results of any further plot commands to the graph. So, I will show you. Let's say hold on. Okay, and then let's say z is equal to x dot cube plus 3x squared, for example, minus 3. Okay, I made a mistake again. 3 times, okay, and then let's say plot z, and then well, let's say red arrow. Let's say arrow. Let's see what will happen here. This is the plot a while ago. As you can see, the first plot, and then this one, this is the red, orange. Okay, if you can see this one, if you could remember, here, red dotted line with circles at the points. Sorry, red dotted line, circles at the points. This is the first plot. This is the second plot. Why it does not cover up this first plot? Because of the hold on command. What is that? This one. Okay. If you put hold off, then it will simply, it will replace it. Okay. So I think you understand that one. So many definitions here, but if you could, if you could understand that one, it will be just fine. Subplot is just creating a lot of figures. 4 plots here, 1 here, and then the right and the bottom, like that. So the meaning is like splits the figure window into an m by n array of small axes and makes the pit one active. So to make it simple, it's just like this. Okay, let's try to use subplot here. Let's go back to the plots again. Let's say x is equal to negative 5 to 5. Y is equal to x squared minus 4. Okay. You could remember, and then if you plot xy here, okay, I'll also write here y2 is equal to x cubed minus 3 times x plus 3, plus 5 possible. Okay, and then let's try to plot. Okay, let's make a subplot. So let's say my first plot in the left side. By the way, let's look at first so that you can see. Plot xy, we have that one, and then if we hold on and then plot xy2, then look at the plot, that one, x1, y1, and then, or y, sorry, and this is y2. Okay, so let's make let's say a subplot. On the left side, plot xy, second plot xy2. So let's say subplot xy, I don't know, 1 1 1, say and then plot xy. Let's see what will happen. Okay, let's try to erase this first. Plot xy. Okay, here. So subplot 1 1 1. Let's go back there. Plot xy. Okay, it's correct. Let's say subplot 1 1 2 on the left, on the right side, left right. So second plot will be sorry. check it again. Let's delete it first. Subplot 111. I don't know, this is 1 to 1 to 1 to 1, sorry. So first row and then first column first, we will use the 1 by 2. There are two plots, okay? We have 1 1 and then 1 2. First row, first column, the left side, first row, second column on the right side. So if you will use this one and then plot xy, we will see. Okay, here this is xy. This is what I'm saying. It will create like a matrix, I mean a row vector, 1 1, first row, first column, first plot, first row, second column, the second plot. Okay, so we can do that one. Subplot 1 2 2. Okay, and then let's look at that one. It's not yet, okay, we have another plot but it's not yet plotted there. Plot xy2. Okay, and then if you see it, here we go. This is the first plot and then this is the second one. Okay, that is a subplot. So here it's well, I didn't flash it already, but it's just like that. Splits the figure. A while ago we have plot and then we have subplot. Splits the figure into an m by n array of small axes and makes the fifth one active, as what you've seen a while ago. So that ends the discussion, the lesson for this chapter. And then with that, thank you.